The turning moment diagram for a multi-cylinder engine has been drawn to a scale 1 mm is equal to 600 Newton meter vertically and 1 mm is equal to 3 degrees horizontally. The intercepted areas between the output torque curve and the mean resistance line taken in order from one end are as follows: plus 52, minus 124, plus 92, minus 140. All these things are given, values are given when the engine is running at a speed of 600 rpm. So here the speed is also given. The total fluctuation of speed is not to exceed plus or minus 1.5% of the mean. Find the necessary mass of the flywheel of radius 0.5 meters. So this is the problem that is given. So let us see how we are going to go ahead with the problem. So first of all, before jumping into the problem, you should understand that what is meant by turning moment diagram. Turning moment diagram is a diagram which is drawn between crank angle on the x-axis and the turning moment on the y-axis. So you can see the turning moment is given as 600 Newton meter for every 1 mm on the y-axis, and on the x-axis it is given as 3 degrees for every 1 mm. So you have to draw a turning moment diagram. Turning moment diagrams are standard for different engines. So different types of turning moment diagrams are already discussed in the class. So please go through your notes to find out which diagram refers to which type of engine. And based on these things, you need to memorize these standard diagrams and incorporate those with the given values whenever such problem is encountered in the examination. So let us try to solve this problem first and see how we are going to go ahead with the problem. Okay. So writing the given data is n is given as 600 rpm. So whenever you are given a speed, you can calculate always omega. Omega is given by the formula 2 pi n by 60. N value is here is 600. So substituting 600 here, 2 pi into 600 by 60, that gives to 62.84 radians per second. And R value is also given as 0.5 meters. Apart from that, whatever other values are given, those values we'll use them whenever that is required. So next thing is that we have to draw the turning moment diagram. And you all know that the standard turning moment diagram for a multi-cylinder engine will be something like this. The crank angle is here on your x-axis and the turning moment is on your y-axis. You can see that whatever values are given, I have incorporated those values in the sequence, in the similar sequence as given. So initially I have considered the point here as A, and from here A, because it is given plus 52, I have drawn it towards the upward direction. So here whatever line you are seeing this line is the mean torque line. Okay, so this is your torque mean line or mean torque line, above which is plus and below the line is your minus. So plus 52, because it is positive, I am going here in the upward direction. Above the line I am drawing plus 52, and this point I am naming it as B. Okay, so next value is given as minus 124. So from here I am going down and I am putting this value as minus 124. You can see that I am dotting this area as I go on. This point is C, and from C the third value is plus 92. Plus will be above the line, so this time I am drawing it above, that is plus 92. Minus 140 is below, plus 85 is above, minus 72 is below, and plus 107, that is the last value that is given. So that is how I am going to end the curve. So I hope you all understood how we are going to draw this curve, and based on these values you are going to go plus or minus, plus minus, plus minus, and plus. So if at all initially the value given is minus 124, you will start from here and you will go minus first, and then plus value is given means you will go plus. So that is how you will be drawing. I hope you all understood this thing. Okay, so next important point that is given here is that the total fluctuation of speed is not to exceed 1.5% of the mean. So let us assume that omega 1 is the maximum speed and omega 2 is the minimum speed. So the fluctuation between the maximum speed and the minimum speed will be your total fluctuation. So omega 1 minus omega 2 is not to exceed 1.5% of the mean. Let us consider that omega is the mean speed. So here he has given that omega 1 minus omega 2 is equal to or that should not be exceeding plus or minus 1.5 omega, plus or minus 1.5, that is minus 1.5 to plus 1.5, the total value is 3. So that can be considered as 3% of omega. So that is what is the given instruction in the question. So since the total fluctuation of speed is not to exceed plus or minus 1.5% of the mean speed, Therefore, omega 1 minus omega 2 is equal to 3%. That is equal to 3% of omega, that is equal to 0.03 omega. So omega 1 minus omega 2 value we have found out from the given data as 0.03 omega. Okay, and next we know that the coefficient of fluctuation of speed, the formula for Cs is equal to omega 1 minus omega 2 by omega, and previously we have calculated that omega 1 minus omega 2 is equal to 0.03 omega. So from that we can write that Cs is equal to omega 1 minus omega 2 by omega, that is equal to 0.03, which is what we have written here. Next, since the turning moment scale is 1 mm is equal to 600 Newton meter, as you can, if at all you can recollect from the question, on your y-axis 1 mm is given as 600 Newton meter, and on the x-axis 1 mm is given as 3 degrees. That is 3 degrees you have to convert into radians. 3 degrees you have to, for converting into radians, you have to multiply it with pi by 180. So that comes up to pi by 60 radians. Therefore, 1 mm square on turning moment diagram is equal to 1 mm square, that is the area you will get by multiplying whatever is the value of 1 mm on the y-axis with whatever is the value of 1 mm on the x-axis. So on your y-axis 1 mm is equal to 600 Newton meter, that is given, and on your x-axis 1 mm is equal to, we have converted the degrees into radians, that comes up to pi by 60 radians. So whenever you multiply these two values, you will get the value of 1 mm square area on the turning moment diagram, that comes up to 31.42 Newton meter. So next is that we have to calculate the fluctuation of energy. For that we require the diagram that we have drawn in the previous slide. So I'll get the diagram here once again. Okay, so this is the diagram that we have drawn in the previous slide. So from this diagram, now what we are going to do is that we are going to calculate the maximum fluctuation of energy. So you can see that the energy is 52 here, 124, something like this. All these things are there. So whatever is are the values here, from these values you will try to calculate the maximum fluctuation of energy, which is very important for us. So how to go about that is that we'll assume that at point A the energy is E. So we'll start by assuming that let the energy at point A, that is the starting point, as E, and from there we are going to do the calculations. Let us see how we are going to do the calculations. Okay, so we have assumed that at point A the energy is E. So at point B the energy will be whatever is the energy at point A plus whatever is the energy that is between the points A and B. Okay, so at A point the energy is E here. Okay, this is at A point the energy is E. So from A to B the energy has gone on the positive side. So whatever is there, I have already explained. This is the mean torque line. Above the mean torque line it is plus, and below the mean torque line it is minus. Okay, so at point B what will be the energy here? That will be E plus whatever is the given value. The given value here is 52. So at point B the given energy will be E plus 52. And at point C what will be the energy here? Whatever is the energy at point B plus the energy between these 2 points, but here the energy is on the minus side, so this value is minus 124. So energy at point B is E plus 52. Okay, so if at all we add the energy between B and C, that is minus 124 to this, minus 124 to this, you'll get the value of energy at point C. Okay, so that is what we have written here. Energy at point C is equal to E plus 52 minus 124, that is equal to E minus 72. Similarly at point D, if at all you want to calculate the energy here, energy at point C plus the energy between these 2 points, that is E minus 72 plus 92, because it is above the line we are considering it as plus. Also in the question it is given as plus. If at all you refer to the question, it is given as plus 92. Okay, so the final value is E minus 72 plus 92, that is E plus 20. Similarly we will calculate energy at point E minus 20, that is energy at point D, minus 140, because this energy between point D and point E is on the minus side. Okay, so that is E minus 120. Similarly we are going to calculate at other points. Energy at F is equal to E minus 35, energy at G is equal to E minus 107, and if at all you observe energy at the last point H, that will be energy at G, that is E minus 107, plus the energy between the points G and H, that is plus 107, that is equal to E. So most of the times you will find that energy at the starting point and energy at the start point end point will be the same. That is, we have assumed energy at point A is E, and what has come at the final point, the energy at H is also equal to E. So both these points will be same. That is something that you need to observe. So once you do all these calculations, energy, we'll see what are the plus values. That is, at point A energy is E, at point B it is a plus value, that is E plus 52. Again plus value will be at point D, that is E plus 20. Again at point F it can be plus value, but because of this huge minus, this has become into a minus. So let us consider the plus values, that is E plus 52, E plus 20, and again E. Out of these, which is the largest value? E plus 52, E plus 20, and E. Out of these, you can clearly observe that E plus 52 is the maximum energy. So at point B, we find that this is the maximum energy. So this point we are going to consider point B as the maximum energy point here. Okay. And what is the minimum energy? For that we have to consider all the minus values. Okay. So minus values here are, what are the minus values? E minus 72, E minus 120, E minus 35, E minus 107. Out of these four values, you can clearly see that most negative value is E minus 120. So E minus 120, where is this point? This is at point E. So point E, we are going to consider that point as the most negative value. Where is point E? This is the point E. I am going to mark it with green. That is the minimum point which is having minimum energy. So why we are doing all this exercise is that we want to calculate the maximum fluctuation of energy. So maximum fluctuation of energy can be obtained by subtracting minimum energy from maximum energy. That gives the maximum fluctuation of energy. So maximum fluctuation of energy can be obtained by subtracting energy at point E from energy at point B. So that gives us the maximum fluctuation of energy. Delta E is equal to maximum energy minus minimum energy, that is E plus 52, which is the energy at point B, minus E minus 120, which is the energy at point E. So that finally gives me the value of 172 mm square, because all these are area values, 172 mm square. But previously we have found out that 1 mm square is equal to 31.42 Newton meter. Therefore, multiplying this to the 172 mm square, so that gives me 172 multiplied by 31.42, that gives 5404 Newton meter. So maximum fluctuation of energy, we have found out that to be equal to 5404 Newton meter. And in the question he has asked us to find out, what he has asked us to find out is that he has asked us to find out the mass of the flywheel. Mass of the flywheel. For finding out the mass of the flywheel, we know one more formula, that the maximum fluctuation of energy delta E is equal to I omega square multiplied by Cs. I is the mass moment of inertia, omega is the mean speed, and Cs is the coefficient of fluctuation of speed. You know all these things. So delta E is equal to I omega square Cs is the formula that we are going to use here. Okay, let us see how we are going to use it. Okay, for that let us assume that m is the mass of the flywheel, which we need to find out here, and delta E formula is equal to I omega square Cs. Further, I can be written as I is equal to mr square or mk square, whatever is the thing given. Based on that, you can write it less I is equal to mk square, or here the radius value is given, so I am going to write it as mr square. Okay. So 5404, I substitute that value is equal to m. This is what we have to find out. R value is given as 0.5 already in the question. So 0.5 whole square. Omega, that is something we have calculated from the given speed. Omega is equal to 62.84 the whole square, multiplied by Cs value. Here Cs value you can find it as 0.03. So once you do the calculation, so this will be, you're getting mass as 183 kg. So that is the problem here. So I hope you understood this problem, how to solve this problem. These type of problems are very easy. You can very well do these problems, I guess. Thank you.